Folks, we'll give it a few moments for others to join and then we'll get started.
Sounds good. Thanks, Paul.
All right. Let's go ahead and get started. Today is July 11th of 2023, and we have Chojin, we have Mike, Rainbow Mango, and Ryan here to talk to us today about the cluster inventory API proposal. I imagine you all brought a deck. I think that you should have screen sharing enabled, if I'm not mistaken, but let me know if you don't.
Let me try sharing my screen. Nope, host disable attendee screen sharing.
Truly bizarre. Okay, I have the button to share my screen, so let me see if I can give it to you.
Sometimes just check and uncheck. That seems to do it.
I don't even see where the security settings have moved to, actually. Huh, okay, I guess I'm not logged in as the host. Let me try to log back in. One moment. Okay. I may need to rejoin. All right, back in a moment. All right, you should have a screen share now.
I do. Can you guys see my screen?
Sure can.
Yes.
Got it. Okay. We don't actually have a deck prepared where we have the proposal doc that's linked to the calendar and we shared it in the Kubernetes Slack. There were a bunch of discussions that took place in the Google Doc, and we felt like it's better we would just go off on the Google Doc and then talk about those discussion points. So before I get started, I just want to say thank you for all the participants that contribute to this doc, especially Q-Jang, who I think wrote most of the doc. And unfortunately, due to some emergency, he's not able to attend the meeting today. Okay, let me get started. So we're proposing to introduce the cluster inventory API. And in a high level overview is in the community right now, in the wild public, there are a bunch of multi-cluster projects. You know, we have OCM, Kamada, ClusterNet, Fleet Managers, and we all have a concept of this cluster inventory, cluster registry, but there's not a standardized API. So, which makes it hard for the downstream project consumers to consume. And we're hoping that we can come together in a community effort to define such standardized cluster inventory API. And then with that established, with the fields well understood, we can make it easier for consumers to adopt this API and use it. So again, you know, we have a bunch of projects that each have their own sort of cluster inventory API yet, but we're all trying to achieve the similar goals. You know, we want to show the status of the clusters. You know, show some data, show some data about the clusters. And then when each of us go to projects and go like, hey, would you be interested in adopting this API? But what the common feedback seems to be, oh, but this is not a standard API. If we adopt one particular project, we have to add some abstract layer and maybe have to adopt another project, and it's just not feasible for the third-party consumers. So with that in mind, we would like to introduce the cluster inventory API, which really gives a foundation API for this multi-cluster management, and it can be used for for multi-cluster workload scheduling. Obviously, you know which cluster have the resources to perform workload, and you can delegate the workload towards that cluster. And then for GitOps tools, again, you know, similar, it allows them to have a list of cluster inventory, and then they know which cluster they can connect to and deploy the GitOps YAML manifest onto that cluster. And then there's some other use case, such as like operation tools, and then exposes APIs to different cloud vendors. And then it provides a vendor agnostic integration for external tools. And I think Mike added this part, the cluster manager implementation for grouping clusters for MCS API cluster sets. Um, Feel free to jump in at any time if you have questions or comments. Mike, do you want to touch up on this right now, or I can come back later?
I don't think there's too much to expand. It kind of jumped out to me as something that may be useful, just given the kind of scope of this project and felt in line with it.
Got it. And one of the main goal of this presentation is we want to get this cluster inventory API proposal out there. We want collect more use cases from the customers. I mean, from the consumers. The more consumers that show interest in this cluster inventory API, the better, because it will help easier for us to shape the API, and then we can figure out more details and come to agreement on some of the standardization. So one of the immediate question is we did in the community, there was a cluster registry API project, and that has been archived. And the immediate question was, okay, why did that archive? And then why are we proposing this new cluster inventory API now? So one of the reasons it was archived, it didn't really have enough adopters and consumers. And so to avoid that mistakes, we bought a bunch of adopter projects that will contribute to the cluster inventory API and shows a commitment to this project and willing to continue to build towards it and actually use it instead of leaving it in sort of like archival states.
So one of the reasons it was archived, and sorry, I hope you can hear me. I'm stuck on a train. One of the other reasons it was archived is because I don't think there was a clear, consistent set of things beyond just a list of kube configs that we wanted to get out of a cluster registry between projects. And I think that's why there wasn't adopters. Is it, I mean, here it's awesome that a bunch of different projects are coming together. I think that's a great starting point versus the last one. But how is that really different now? Do we know that, like, there's a lot of lists in this doc on, like, we want to show status, we want to show health. But I think for me, what stood out as the points that really need clarification are, like, what does health mean in a consistent way such that it can be consumed by all of these projects and they're all happy with it? What is useful status? Because that is, I think, a deceptively tricky question.
Got it. So, so we're hoping that there's third-party projects that will come out and then saying this is what we want out of this cluster API, cluster inventory API, for example, where you said how to define the health status, and then we can come to a quorum, and then we can actually, you know, when we propose the API, we come to a conclusion and then come to a standardization. So that's why I think it's important that we already have, you know, a couple of projects that are willing to work together, and then we come to sort of agreement. So at the very least, we satisfy some of the consumers' requirements already, and I think that that's a really fair point, and I think that's something that we need to keep working on this cluster inventory API. We're just actually getting the consumer specifics of what they're looking for, so we can really help shape the API and to have the right specifications.
Awesome. Yeah, maybe we can start with just by adding to this doc a list of those kind of questions. I mean, I think a lot of them are in the comments, but maybe we can, like, pull them into the body so they can be discussed in their own comments.
Got it. Okay.
I think this is in a much better position.
I think I saw one iteration of this document that actually did propose, like, why would people try to use it? Why would it be beneficial? And one of the use cases where it would be beneficial is trying to build a project that wants to install across multiple clusters or put its add-on across multiple types of multi-cluster solutions, and doesn't want to have to write one for Carmana, one for ClusterNet, one for each of the varying ones. By having a cluster registry, it is possible to build that next unit on top of it. So once you have the idea of this cluster exists, you can say, okay, now I have this group of clusters that exists, and I want to use that to be able to place my work on top of. I can see that as a very useful next step.
So I think that's really good. Like that, I think clearly that is kind of what we want the cluster registry for. Right? There's a list of, like, ways to access clusters. But then I think when we go to the next level, there's still a lot of open questions. I'm not saying that is, I think, a good direction to explore. But some of the questions that come up are like, okay, so if I wanted to schedule across multiple clusters, what do I need? I need to know that my cluster has capacity. What does capacity mean, right? Like, it's not a number. I think it is often thought of as a number, but it's not just one number. Like, there's my ARM capacity and my x86 capacity. There might be my GPU capacity. There might be my GPU of a certain kind capacity. Those are the kind of questions that come to mind, where I think, like, picking a use case like that example is a really good way to kind of enumerate the, like, next level questions.
So one of the things that I felt that, like, cluster registry as a project, like the previous project named a cluster registry within the SIG, really had a miss on is there was really no good answer to the question. I install this registry CRD, and the cluster registry, I don't think, and I may not be remembering this exactly right, but I don't think there was any code that we ever wrote around it. It was basically just a custom resource definition. And so it's like, all right, well, I installed this cluster registry CRD, now what? And there's like no consensus even on what that next step should be. So I think that your document that you're sharing has a lot of great ideas in it. What I think would be profitable for you all to think about is when someone asks you, I installed the cluster inventory API, what do I get out of it? Like, what's the first answer that you give them that demonstrates tangibly that there's something there worth using and that it has a specific and clear purpose? How would you answer that question today?
So currently the cluster inventory API, it's, as David alluded, it was meant to be a foundation API that we can continue to expand on. We're really hoping that, once we have this cluster API, we can continue to build on it on top with something like placement and maybe the work API to leverage. So I will say right now, if we have the cluster inventory API, because the work API project already is in the SIG, I will say now you can leverage the work API to pick the cluster that you want. I mean, you have to specify the cluster inventory API, cluster inventory that you want, and then it'll deploy the workload there. And then it's a little bit of future goal, but right in the middle, we would really like to introduce the aspect of placement. So without the cluster inventory, I think it's hard to do the placement, and the placement is about picking which cluster inventory to do something, whether it's to view or deliver some workload or do some other actions on. And I think that is what we're trying to do. We're trying to build a foundation layer so we can continue to build on top of it. David, do you want to expand on that?
Yeah, I was gonna go like specific and concrete, right? So looking at this and saying, why would something outside of the Karmata project care about this? Or why would something outside the Open Cluster Management project care about this? Is a very fair question. And I think being able to show sort of I'll say 4 core APIs. If you have a cluster inventory and you have a placement decision API, you don't even necessarily need placements, but placements make it easier to use and would show a general sort of scheduling capability. And you have a work API, you can build out of the combination of those things a way to distribute work across multiple clusters and say, I want this here and that there, with decisions around the around things like label selection or cluster properties and anti-matching with something like taints. And so the question becomes, how big a slug would the SIG like to see at the same time, right? Is it a case where build all the pieces out and show this is how, given just a cluster inventory, that a project says, here's my cluster inventory, we can have these 3 more generic pieces on top, and they provide the value? Is that desirable all at once, or is it desirable to show a design for that all at once, or a working implementation? Like in terms of a next step, how detailed would that need to be?
Well, David, I take your points. What I was really coming at was not that I think that we need to see like those 4 essential building blocks. what's in my head is that, you know, without an essential use case that like demonstrates the value without those additional building blocks, this starts to feel very much like cluster registry 2.0, where we've got a CRD and it's really not clear what an essential thing that you can do if you've just got that CRD and almost nothing else are. Like scheduling and placing workloads, that's a very high value and high impact use case to have, but like it also brings in a lot of other pieces, right? So what I think I'm kind of poking at here is, I think the cluster inventory API as a concept gets stronger if there's a controller that you can run that at least heartbeats into it, so that you can get like a view of your fleet at some very low level of granularity without doing a whole lot else. I think other opportunities would be if we can, if we have projects that are lined up so that we can say, you know, at some point that if you install this and you're running Karmada and you let Karmada know where the API is, all your stuff from Karmada is just going to start showing up there. And all your stuff from Open Cluster Management is just going to start showing up there. Then it gets a little bit more clear that that there's a useful direction that it can head in. But I think what we want to avoid is an experience that's like there's a CRD, there's nothing that integrates with it. You just install the CRD and like then you like, I guess, use kube control to like enter your data about your clusters type of thing, because that's what you'd get out of reading the cluster registry README, and it's just not enough to be compelling.
Yeah, I guess that's why I was bringing up like that roadmap, that roadmap of you have the inventory and you move from the inventory to the idea of placement decisions, and then you mix in the idea of work to be able to distribute work into those clusters. That is the concrete next step. And the question that I have is just how much of that needs to be built out before taking the first step. Because it is
actually,
yeah.
I'm curious, actually, a different angle. Like, is this about actually building a generic cluster inventory that can be used for all sorts of multi-cluster things? Basically, yeah, cluster registry 2.0, or is this actually just instead a common API for workload placement that all of these open source projects can consume? Like, are we standardizing the work API, Karmada APIs? And the cluster registry is just a bypass of that, or a byproduct of that.
I think being able to demonstrate that next level of value of like, why, as someone who wants to work across multiple clusters, why would I bother using this thing? Is the question that I would want to answer, because otherwise, like, how am I going to convince Argo CD to use it, for instance? And the value there comes in saying, you know what, if you interact with this higher level API, then these 4 projects will just distribute your workload for you, and it will report status the way that you expect. I think that would be a compelling reason to come and use this project and make it notably different than a previous attempt. And if it's just a matter of like making concrete, like here's the next step. It's not like a theoretical, we're building it and hoping we have something. It's we're building it, and then this is the next step to take that will interact, will bring these 2 other pieces together. That's certainly doable. And I could see saying like that's the threshold. Like you have to have a working thing where someone could say, yeah, I get a unit of value out of this. Because yeah, I do agree. Otherwise you end up in a situation where, well, great, you built a cool thing, but why would I bother spending my time to integrate with it?
Or equally concerning is the we end up with a CRD that appears really useful, but ends up being like still a like product specific set of key value pairs with no real consistency. That's kind of my big concern. Like the concept to me makes a lot of sense. This seems like something that like intuitively the community should have. We haven't been able to have consistent answers to those questions in the past. that's it. So I think that for me, that would be like the most compelling place to start. Is
So,
like,
to
what are
that
the
degree, I do
commonalities?
think that we will get more standardization once we demonstrate a unit of value where someone would actually have something that spans across, right? If you don't have any mechanism to span across, it's just as easy for you as someone trying to code to the different multi-cluster solutions to say, well, I'm going to code to this one and it works this way, and I'm going to code to that one and it works this other way. But once you have that unified thing, you can see, oh, here's the value that I get as someone who wants to work on top of this. And now I need these contributors. Like, come on, guys, come up with some sort of standard on how you're going to name what you have available here.
That makes sense. How is that different materially from like just like each of these listed projects already has a inventory system for clusters, right? Could we just pick one and say like, we like this? The others should converge.
I'll let somebody else answer that. I'll let someone else answer first, and then I do have an opinion.
Yeah, so I think we thought about that, and that's kind of the purpose of this inventory is we try to get to a point that everybody can agree with one standard. Every project has its own viewpoint, so that's kind of the main purpose of having this cluster inventory, so we can have one standard one. The short answer is clearly it's not easy for everyone to agree to conforming to one project. That's why we have this this proposal, so that we can actually converge. And that is this standard that we discussed for almost 3 months on the nitty-gritty details on every fields, what is needed, what is useful. So this is kind of the product of trying to converge.
So maybe we can examine the same question a slightly different way. So like say that this cluster inventory API proposal is accepted into the SIG. What specific things are which open source projects going to build that use it, that can become part of that future README? That's like, all right, I installed the CRD. What do I get now? Like, what questions, what answers to that question are going to be built if this were accepted?
Yeah, the fleet manager, I can represent fleet manager. Fleet manager project definitely is going to implement or use this cluster inventory. That part I can, I can assure that.
So I also mentioned in the beginning, we have commitments from the aforementioned projects that will use it, and we also reach out to the Argo communities, and they're also interested. And I think besides these projects, I mean, I think Stephen can talk about it as well. Even in some arenas and other projects too, they all have a concept of cluster, but everyone is doing it a little bit differently. Maybe in Argo CD, it stores a secret, and I think a lot of, based on the feedback, a lot of projects are looking for something like this in a SIG, but there is no centralization, so each of them will come up with their own way. And going back to going back to your being usefulness, do you think this project will actually help with if we have a reference implementation controller for the cluster inventory? Because I think Ryan was saying he was interested in that too. Like if there's a like at least provide some heartbeat or some simple status.
Yeah, we can definitely
that-
provide
here's-
a
question.
reference implementation. That's if that's helpful.
Here's a problem that I'm asking you all to try to solve. It's not a technical problem, really. It's a social problem. And the social problem is, how do you demonstrate the usefulness of this like very low level building block without having to have the entire house built already around it within the SIG? Okay. So there's a couple different ways that we could do that. One is we can build something that people themselves deploy specifically to make this inventory API useful. Another would be if this proposal was written as these 4 projects want to all do these 3 things, and they think the priorities are number 1 is X, number 2 is Y, number 3 is Z. And we want to build this API together so that we can then immediately build these use cases on top of it. I think that's very different, right? Than saying you can then do blah versus saying we want this so that we can do blah, right? Is pretty different. In the second formulation, it would allow you all to make a claim that in that essential document of the README in the root directory of the repo that you'll create is what happens next, right? What happens next is, if you're a user of one of these 4 projects, then you get some use case that automatically gets representation in this API as soon as you install it and let them know where it is. So does that make sense? Like, Jeremy, you and I have talked about this a lot. Does it make sense to you what I'm trying to say about
Yeah.
do we build something that legitimizes this, or does it prove to you its legitimacy by virtue of already working with things that people may be using?
Right. Yeah. I see that as the compelling thing. Now, I also see that actually with kind of the plan. It's like we've got 4 projects coming in here that are saying we want to build this API and we're all going to use it. To me, that is, and we're going to use it because we want to have that portability and consistency. That's super compelling. Makes a lot of sense. And I think Paul lines up exactly with what you and I have talked about in the past in this area. Like we get that standardization, we prove legitimacy by the fact that these products all use it. And I think naturally, if these 4, especially because it's these 4 that people know about, are using the standardization, the 5th one is going to as well, right? Like that's super compelling. For me, a lot of the concerns, and I've commented these at the docket, more around like specifics. Like I think we say things like tracking the cluster status, but it's not clear to me that we actually really have a detail on what that status should be, or what health means, or what capacity means. Because like right now we show in the YAML that like there's 10 CPU available, but that doesn't, like, speaking from the GKE side, 10 CPU is not a useful stat, like beyond basic workloads, because I don't know what those CPU are, and they're not interchangeable, right? Like there's 10 good CPU and 10 incompatible CPU. There's 10 high performance CPU and there's 10 low performance CPU. And there's workloads that don't want to be the one. We need to define that in a lot more detail, I think. Health is kind of similar. Like not every aspect of a cluster needs to be running at 100% for another workload to function just fine, right? All of those things are, I think, very useful pieces of information. And like we could start with something basic, but I think we'd hit a wall quickly. So it'd be good to dig in and see like what are the
Jeremy, your audio is breaking up very badly.
Yeah, I cannot hear you very well. Jeremy, we cannot hear you very well.
Of course, now none of us know whether
He can hear us.
Yeah.
Yeah, but I get a point. Yeah. I think that's a good point. We need to decide. Yeah, he's
still talking.
Yeah, that's very good feedback. Anyway, whatever he's saying, yeah, that's very good feedback.
So I think you all have a good opportunity, right? Like you have the advantage over the the previous cluster registry project in that there are already people solving these these problems in different projects. You're already talking with one another, right? If you could agree on a feature that you all wanted to build into your project, into each of your projects, that is going to work correctly as soon as you install cluster inventory API and like point those different, instances of those projects software at it, it gets a lot stronger as a proposal.
I have a concrete suggestion for what those are. Just throwing out, if I looked at it and said, what would bring other people in? I think being able to look and say, these are the selection criteria I have, positive and negative selection criteria, focused around perhaps cluster properties. I know that was one that came up previously, or the notion of taints that will be filled in by a project, by whatever logic that project has for saying, I have a thing, would make it possible to build a later step that is a cross multi-cluster solution scheduling. So you can say, I want to be on things like this. I think that would be very high value. And if the 4 groups can agree on that, it would imply the next step and give a lot of confidence for people who'd be looking at building on top, right? Because it would show like, this is what comes next. And we've made it possible. Here's the criteria that you can see. Here's the health of the cluster, because you're going to want to select on that, and the selection criteria.
So Paul, and David, so for my understanding, what you both of you are saying is, in each of the aforementioned projects, we should have either in a README or in a doc where it's kind of showcase not even a commitment, but actual use case of the cluster inventory before the repo even exists. Is that what you're trying to say? Before the actual repo is created in the SIG, or having the API group and the API name defined, we should at least on a high level talk about this particular cluster inventory and how it can be used among those projects. And then having those 4 references mentioned in this proposal will carry more weights. Is that what I'm understanding?
Yeah, I think if there was a proposal that was like, projects A, B, C, and D all want to build feature A or feature X and feature Y, and it's really, really specific, that gets a lot easier to feel like we could potentially accept, the cluster inventory proposal without winding up in a situation where it's just cluster registry repeat, right? So like, I am not suggesting that you make changes to software before you have the name figured out or the repo created, but having a compelling plan that results in, hey, we get these actual concrete use cases that people are going to build as soon as they've got the CRD defined to build against, it gets a lot easier. Does that make sense?
Two things. Actually, on the fleet manager side, we could even start with a reference implementation. The only problems, we don't know the CRD exact definition. If there, we could even start with a use in the SIG repo. We can actually give a reference implementation there, and we are going to use that in our real repo, if that will make it more compelling. Another thing is, I think Thomas has a question. He has his hand raised up for a while.
Yes, thank you. I just want to speak to potential use cases, and I wanted to plus one what David had said, which is essentially the use case we're interested in, which is the basically scheduling between multiple clusters and taking into consideration everything from taints and tolerations, affinities and anti-affinities. In my ideal world, this would support basically being able to mirror the entire Kubernetes scheduler design that's used to schedule between nodes for picking which clusters are available, right? And so I just want to plus one that as being a use case that I see as a lot of value. And that's actually the use case that even drew me to this SIG in the first place. So that's all.
Yeah, just want
I'm just
to
gonna-
add to that is
Sorry.
I think every project that is behind this has what Thomas was saying. We all are building this type of capacities, capability with various degrees, but the common denominator is that cluster inventory, the unit, like kind of the node, right, in the Kubernetes. We don't have a representation of node, common node. So this is the exact reason we want to have a standard representation of a cluster. So all our schedulings can be based on that.
That makes sense to me. And I'm sorry if I drop off again. I'll try to do it there. I think that as a primary goal makes a lot of sense. I think the original description was more generic. We're building a platform for scheduling is a very specific, and I'm sorry if it's changed. I've been out for a couple of days. We're building a platform for scheduling is a very specific goal. It makes a lot of sense.
Got it, Paul. Thank you, and Jeremy for that feedback, and Ryan as well. So I think going back to Ryan, I mean, I think it'll be great if we have again all the projects come together and then clearly define in our own repos or website or somewhere that we're trying to build we're trying to have a common API where we can use to as what Jeremy said, we're trying to build a platform for scheduling, and maybe not necessarily we need the code yet, but at least it needs to, each of our individual projects should mention this point. Like we should have a issue or enhancement where, you know, we're gonna adopt this. We're planning to adopt this common API, and then that is what gonna enable the users to be able to maybe even switch back and switch from one platform to another, right? In maybe some migration scenarios, so that if they have the cluster inventory, they can use OCM or Fleet Manager or Kamada or whatever. It all gonna work seamlessly. Does that make sense, Ryan? Or?
Yeah, definitely. Yeah, that I think that's the goal. As
And-
David
and,
says, yeah, it's the building block, right? We have this kind of conundrum or chicken and egg problem is we cannot get the entire stack, the placement, decision, scheduling, everything together. If we then we have to do the baby steps. So the baby steps start from the standardized cluster. Hopefully we can show the community that this is the roadmap, and that's the value of providing this small piece that doesn't by itself may not have a tons of value, but we have this roadmap. But without this, we cannot get stuck. So we have to start from somewhere.
Okay, so based on the feedback from Jeremy and Paul and David and everyone else, so I think our next step is for our projects to sort of create that roadmap, and then we'll come back in the proposal here and list the clear goal as what Jeremy suggested, and then also answer some of the questions and bring in some of the questions regarding the specific of the fields, such as the capacity, that example that Jeremy mentioned. And then after we examine the proposal again, are there any other, we just would like to ask, are there any other suggestions or feedback we can really push this cluster inventory API repo to be sort of created in the SIG, so we can start implement it? We just want to know what are some of the, besides the mentioned points, what other things that can really help push this forward?
I think
I
that's
think
a,
the biggest thing you can do is give us a reason to think that we won't just have a lot of awkward conversations in the future about what is this thing that has no real answer.
Got it. Got it. Honkai, do you have any comments or any feedback? Because I think we basically went through our discussion. We went through all the most of the proposal already, and there's still some work that needs to be done, and we'll keep appending to it. But Honkai or anyone else, any other feedback?
Thanks, Mike. Yeah, I think it's a good thing for all projects have a common API, but I feel it's might be a little challenge for these projects to adopt the new API. Yeah, but I think I will work on this proposal and see try to make agreement.
Thank you, Honkai.
there any comments from the community? That would be very helpful, like outside of the full project that is proposing this API.
I would just like to mention that I think the community also has been asking for some type of multi-cluster scheduling capability, and they're looking at the SIG. And then I know we archived the QFET rightfully so, but I think there's a lot of demands for this scheduling capability for multi-cluster. So we would really like to meet the community demand and try to build towards it, and hence this is another reason of why we're starting with this sort of a foundation block for cluster inventory as well.
I mean, it makes a lot of sense, and thank you for coming to present it. I think like this is intriguing. It's just a very, very hard problem, right? And so if we can solve it, amazing. And I think, you know, to a lot of the points Paul has made, just if we could really kind of de-scope and focus on what is the immediate value and the specifics, it's going to be a lot easier to see a future.
Got it. Understand. I don't really have. Oh, there's someone with the hands up. Oh no. Okay. I don't have anything else. Anyone else have anything they want to share, mention, feedback?
So what's the next steps? I think we will come back in 2 weeks and give a different some update on this proposal. That sound good?
Yep, that sounds great. I for sure will each project will go create some type of roadmap that's related to this this proposal, and then we'll come back with a enhanced proposal. Yeah.
All right, well, I think that was it for the agenda today. Thanks for presenting. And we'll look forward to seeing more iterations on this work in the future.
Thank you, Paul. Thank you, David. Thank you, Jeremy. Thank you, Ryan. Thank you, everyone.
Thank you.
Thank you,
Great
folks.
discussion.
All right.
Take care. Bye.
Have a great day.
Bye.
See ya.